So this is my collection of battery wall clocks, and each one of these clocks uses a very slightly different way of keeping time. This first one is completely mechanical, really. All it's doing is it's using the battery, this very large D-cell battery, to wind the mechanism. As you can see, there's a balance wheel escapement in this, which is entirely mechanical. And then here is a spring, and this motor winds the spring up. I think it's every 7 minutes, and that keeps the whole clock regulated. I'll just see if I can try and get you to see. There we go. I think you can just about see it there. That's the balance wheel. The next sort of step was doing away with it being wound up mechanical clock, and rather than winding the clock up, they actually used coil and a magnet to make the balance wheel rotate and advancing the clock. This one's by Remington. This is quite nice because it's a Swiss-made one, sort of a transistor clock. The transistor keeps the oscillation regulated, and it moves this wheel, which advances the clock, moving the clock on. As opposed to the spring advancing the clock on this one, this actually uses the balance wheel itself to advance the clock forward. And it's jeweled. It's quite a nice jeweled movement, and it's very accurate, this one. The next step, if you like, is the tuning fork clock. This one is by Smiths, and if you see the little tuning fork logo, it's very shiny, this clock, to try and very reflective. This is the movement of the back, and what I've done on the television is try to blow this up. If you look at this movement, this and the green coil is, as I orientate it, is basically like this. So this is this, the green coil is there. Now you can see these two magnets are on this U-shaped piece of steel, which is the tuning fork, and these coils vibrate at the ends of this tuning fork, which through magnetic connection propels this wheel, which is driving the whole clock, which gives it this very smooth movement. And if I put it up to the camera, you may hear it humming, but I'm not sure. So you had these out in the, I think, mid to late 70s. This was mid 70s, and this would have been late 60s, early 70s. And then the next step was the quartz clock. Now this very large Toshiba quartz clock is a very early quartz clock. Again, probably from the later 70s or even mid 70s, I'm not entirely sure. I think quartz clocks became really affordable in about 75. So this probably is just a little bit earlier than that. As you can see, it's a sweeping quartz mechanism. It doesn't use a stepping motor. Most quartz clocks step. You can hear them tick, tick, tick every second. And they use the stepper motor, whereas this is using a motor that spins continuously. I can show you the mechanism on this. This is basically the motor here. This is the coil that will drive the motor. And this is actually a jeweled movement, so it's very accurate. It even tells you on here that you can set it to the TV or radio time signal, so they're obviously expecting it to be quite accurate. The actual quartz part is in a further projection up here, which you can't see. This little hole here leads to where the quartz crystal is. Another nice thing about this quartz movement, as well as being jeweled, when you pull this setter out to set the time, it automatically resets the second hand to the 12 o'clock position. So as you follow the instructions, you can set it just on the time signal at the 12 o'clock position. A nice thing about looking out for these early quartz clocks is there's several different types of mechanisms they use, but they don't currently make very good quality accurate quartz mechanisms at the moment. They just make very cheap quartz clock mechanisms. So if you see them, it's worth picking them up if they're cheap enough, because there just simply isn't anyone making really good quartz mechanisms currently. So yes, look out for these Japanese early quartz clocks, because they will become quite collectible, and they're nice accurate clocks to have. Much far better quality than you can by today.